Most users conceptualize an operating system as a single, inseparable block of code. You expect a unified, rigid entity. But Linux fractures that concept. Linux functions as a central kernel, a core layer that manages hardware and serves as the foundation for thousands of distinct software configurations. This is the logo for Kubuntu, a specific software configuration. We will use it to map how these systems are built. To read this diagram, we split it into two halves, the outer segmented circle and the central K surrounded by gears. We can treat this design as a high-level map of the system structure. The outer circle represents the stable back-end infrastructure, while the central elements signify the customizable interface layers. We will map this stack from the kernel up to the display, analyze the underlying C++ toolkits that generate this environment, and define the exact deployment use cases for IT professionals. Understanding this specific modular relationship provides a framework for analyzing how various Linux distributions are assembled and maintained. We start at the absolute bedrock, focusing on the bottom two tiers of this four-tier architecture. Layer 1, the Linux kernel, manages your CPU and memory. Layer 2, the base OS and APT, structures directories and manages software installations. Returning to our source schematic, these two foundational layers are represented by the outer segmented ring, the traditional Ubuntu motif. Because Kubuntu utilizes this exact same foundation, everything under the hood is mathematically identical to a standard Ubuntu server. Core network configurations, security patching, and package management run exactly the same way. This shared backend is invisible to the person at the keyboard. The user-facing reality, what you actually click and drag, is handled higher up the stack. These bottom layers guarantee enterprise stability and security, but they dictate nothing about how a user interacts with the machine. We move up the model to layers responsible for drawing pixels. Layer 3 is the display server, the raw translator for the graphics card. The top layer is the desktop environment, the suite providing windows, taskbars, and applications you interact with. Looking back at the Kubuntu logo, this top layer is represented by the central K. That letter designates KDE Plasma as the specific desktop environment chosen for this particular distribution. This is where divergence occurs. Standard Ubuntu utilizes GNOME, built on GTK using C. Kubuntu utilizes KDE, built on Qt using C++. C++'s object-oriented nature dictates how applications are drawn and memory is allocated, contrasting distinctly with GTK. The choice of UI toolkit results in entirely independent software ecosystems, both running on top of the exact same Linux kernel. We are left with the final visual elements of our source artifact, the three surrounding gears. These represent granular modularity. Where standard GNOME enforces a rigid, unified design philosophy, KDE adopts a decentralized, malleable approach. The architecture lets you swap almost every component, altering window behaviors, rebuilding taskbars, and rewriting rendering rules. Historically, loading these independent modules caused high RAM usage. Today, aggressive Qt optimizations and caching maintain this modularity while remaining resource competitive. Kubuntu's architecture grants administrators the tools to craft a bespoke user environment without compromising the standardized enterprise-grade Ubuntu core beneath it. Every layer and design choice within this diagram is now mapped to a specific technical function. This deployment matrix illustrates how system administrators must evaluate deployments based on user friction and resource constraints, rather than aesthetic preference. In a high customization scenario involving Windows migration, KDE's default paradigm, featuring a traditional start menu and taskbar, maps cleanly to legacy Windows logic. This reduces training time for migrating staff. If dealing with resource constraints, administrators must exercise caution. While the baseline OS is optimized, deploying heavy widgets and custom modules will impact RAM, which requires tuning when provisioning older hardware fleets. In environments requiring strict enterprise homogeneity, there is a dependency trap. If a fleet relies heavily on GTK-based applications, deploying the Qt-based Kubuntu means the system must download and load redundant toolkit dependencies to render those apps properly. In the Linux ecosystem, the desktop is not the computer. It is an application suite running on top of a shared core. Choosing a distribution like Kubuntu means electing to deploy a specific modular workflow toolkit for your end users.